Testing. Okay, here we go. Okay, in the movie about lander.pov, which is assigned in the Newton's Law 1 chapter, it's about landing a little rocket on a hypothetical planet. The physics goal of the movie is to test your understanding about how a force vector can change a velocity vector. So once again, it's a lesson in the mixing of the vector from the first 2 weeks about velocity and now the new vector on force and how those two things can affect one another. That's the lesson. So think F and V as you work through this movie here. If I just download the code and render it outright, here's what I'll see. I'll see a little rocket over here, which is falling towards a planet. So you can tell it's falling because the velocity vector is growing and growing and growing. The rocket initially started at rest, but it is going down. So it's falling down, being pulled towards the planet by the planet's gravity. What you would like to do in this movie is get this rocket to not fall violently down here into this abyss, but to thrust itself by applying some forces on it so it can go over this mountain here, down through this valley, and land safely on this green landing pad right down here. That's what you'd like the rocket to do. So you don't want to crash down there. You want to land as follows on this green pad here. So what are you going to do? Well, in order to start to get it to steer over these mountains right here as it starts here, you need to start applying thrusts on the rocket so it can, in the first part, get over this mountain right here and then get into this region right here, then figure out how to steer it and stabilize it so that it'll eventually fall very gracefully and hit this landing pad. How are you going to pull that off? Well, let's take a little tour of the code here. If you look at the code, just like force maze and force well, I'm giving you an initial position of velocity which you are not allowed to touch. So this is where the rocket starts over on the left side of that mountain here, and we're starting it at 0 velocity, so it's just starting in rest right there. We have a couple other variables defined here. Here's the mass of the rocket. You can change that to whatever you want or just leave it at 1. And also we have a g defined just for convenience for ourselves. That'll be the downwards acceleration due to gravity. So it looks like we're operating on an Earth-like planet that has a g of 9.8. Last, as we keep going here, it's almost like the force maze and the force well, in that I initially have 0 net force on the object. So unless I say something else, we'll just say that the object is not going to have any force on it. Then as I keep going, here's a first sort of exercise in our law that we're trying to get our heads around now, that acceleration is the sum of the forces divided by m. So if you look carefully at what this statement tells me here, I do have a little sum going in here. In particular, I have sort of a rote vector in here, which is 0 minus mg0. So I have a minus mg along the y direction. That's the weight of the rocket right there, which is always pulling it down towards the planet. And then here's the superposition. I have a plus F in here. Now F is the thrust force, which I'm allowed to supply myself. Initially, I do have it 0, but if I put something else on there, it'll be a non-zero contribution to this overall sum, and maybe I can get the rocket to steer around those mountains. So here's my sum of forces right here, a combination of weight plus the downwards thrust, or some, not downwards thrust, but some thrust, which I'm allowed to apply. And then, of course, I divide by m to get my acceleration. And once my acceleration is known, then those are happy to be fed into the physics equations right there to predict where the rocket is going to be a small dt in the future. And that's sort of the goal. So the goal of the movie really is to configure what forces or thrust you want on the rocket to get it to steer over that mountain and land very softly on that green landing pad. Now, there's a bunch of stuff that I added in here just to add a bit of video gameness to it. Don't touch these or even worry about what they do. They're not going to be on an exam. Just forget about it. It's just a bit of an effect for you right there. But what these lines essentially do is it sees if you get your rocket over the landing pad, that's what these lines ask right here, and your downwards y velocity is less than about a meter per second, will draw you a nice landing message on the screen. But if you happen to get over the landing pad and your velocity is too large, we'll give you a big "you crashed" on there. So just a bit of classic nostalgic video gameness for you there. But again, don't worry about these lines at all. Don't touch them. Just let them be in there so you can get a little bit of effect. As you go down, of course, you can draw your rocket and your vectors in there. And these are the ones that draw the mountains, so we don't want you to touch these either because we don't want you moving or changing the mountains. Leave those alone, although I'll give you some hints on how to speed your work along in just a second, but just leave them alone for now. So these two lines draw the mountains, these lines draw the landing pad, forget about the rest. Okay, so here's what are we going to do then. We need to start figuring out what thrust we're going to need to get this rocket to come over the mountain. So it looks like even as early as 0.05 seconds in the movie, I'm going to want some thrust probably that's up and to the right. So if I can imagine a big force vector sticking out of this rocket up and to the right, that seems like it'd be a good first start. And so, by the way, this number of seconds that you see elapsing up here are what are the global time in the movie. Those number of seconds are what are contained in in our movie, in our code here, called X time. I think I've referenced it a few times before, but if there was a clock somewhere on the wall of our movie, it would always read X time starting at 0. Normally, we don't pay very much attention to it. We don't need it very much. But in this particular movie, we're going to apply forces at given times throughout the throughout the succession of the falling here. So it looks like very early, like even at 0.05 seconds, I really want to get some thrust on this rocket that's up and to the right. So if I do that, then I'll go back to the code here and I'll say, all right, here's where I'll have zero net force unless I say anything. But below this line here, I'll say something like if x time is greater than or equal to 0.05. That's the sort of the time I read off that gray clock there. Let me go ahead and apply a thrust to the rocket, which is going to be something like, I'll put 5 newtons along x, 5 newtons along y, and 0 along z. So those to me, the +5 and the +5 mean an fx is 5 and fy is 5. That's going to be a force that's up and to the right. If you look at the overall force those components will provide. And then I'll put the end statement in here. So once again, 0 net force unless I say anything, but now I am saying something. If the time in the movie is greater than 0.05, apply this force, which is up and to the right on the object. Okay? And lastly, of course, I'm going to want to see that force vector. That's part of the course the assignment here, the requirement, what we're looking for when we grade. Looks like all we have is the v vector on here. So I'll just go ahead and copy this line here and paste another one down here, which is going to show me what that force vector is. So there's an F right here, and I'll label it F, because as I start applying those thrusts, I'm really going to want to see the direction they point. So here we go, 0.05 seconds. There's my force vector on it. And now, so what I'm seeing, of course, here is the velocity vector is starting to sort of rotate over into the direction of the force vector as it's supposed to do. Let's see what effect we get. So the velocity vector is not getting covered by the mountain. That's okay. The rocket's still falling. And it looks like I'm going to hit that mountain. Yeah, it just doesn't look like that was enough force in that case here. So I need to sort of get some additional stuff in there. So I've just crashed it. This won't be acceptable. And no, you can't go through the mountain on your final assignment in there. So I'll just go back to the code. It's no problem. I'm totally in control of whatever thrusts I need here. So it looks like to me what I needed, instead of just going over like that, I definitely needed sort of a larger force, I think, in the y direction. I'm really going to crank this up to something like 15 or something like that. And maybe I'll even back it off a little bit. Maybe I'll just leave this at, well, I'll leave that at 5 and see what happens. But this is your job here. You know, what thrust do you want to apply? So I'll just get a much bigger force on it now, up like that, and looks like, yeah, looks like I'm getting my velocity vector to steer up a bit more. So looks like a thrust like this is probably a better bet here to at least get me over that first mountain there. So I'm going to start going up like this, and there's my velocity vector going out. So there is a bit of fakeness in here, so it looks like the engines are all straight down, but clearly the thrust is up and to the right like that. And so it looks like I will be able to bring my rocket over the very top of this mountain here. Now what you have to do for your next step is watch this time here, so 0.68, and as the movie sort of proceeds here, and just see where you get. Your times are going to be different than mine, but it looks like at some point now I can probably back off on that force. Like if I reach the 0.84 here, looks like I don't need that big thrust anymore, so I can do something like if x time is greater than or equal to 0.84, I'm going to want to do something different. Now I'm not exactly sure what, but I'll put some other force on here. Maybe I need to back off, or maybe I even want to be in free fall for a while to let it fall through that abyss a bit. I don't know. It's up to you. So a couple things. Don't go copying these numbers into your code. Your numbers will be different. So don't say something like, well, my 0.05 was different than yours, or my 0.84 was different. The reason being is because I'm actually rendering this for just about 30 frames or so. Like my rocket would have stopped very quickly after it started there. You're going to need something like more like 200 or 300 or 500 frames to give yourself enough wiggle room to actually get you down onto that pad right there. But in either case, that's the gist of the movie. The solution to this, to get your rocket to land on the pad, I believe will just be a succession of if statements that go down. You might have 10 of these by the time you're done. And it seems like to me every one of these times that you put in will be a little bit bigger as it goes. So anyway, it looks like I'm getting a phone call. So happy landing.